Okay, so I have my data. Does anybody else have theirs ready to go?
I'm just lost.
Uh-oh. Okay, well, is anybody not lost and ready to share? So that we can get everybody unlost. Nobody's ready to share? Is everybody lost?
I mean, if you look at it, the higher the concentration, the lower the score.
Also, you could just, well, true, but I guess, and you could make a very general claim from that. You also can just jam it all in your calculator, right?
Yeah, but I'm just like the wording is very weird and I don't quite get what's asking me to do.
Okay, let's go ahead and talk about this then. So let me switch my sharing screen so that you guys can see the document camera. Here we go. Okay. All right. So let's see. Warm up 9, 22, 20. Okay. And so it says it gives a description of the experiment. So group volunteers were given LSD. Their mean scores on a math exam and tissue concentration of LSD were obtained for n equals 7 time points. That just means that there are 7 of these individual data points. So this was the LSD concentration in their tissue. This was the score on the exam. And it says classify the relationship between the concentration of LSD and the mean performance being these guys, on a math exam as shown in the table on the right. Okay, so if we were to do this on the calculator, if we weren't to generally just look at this and look at the LSD concentration going up and the math score going down, what would we do on our calculator? Call names. It's not a volunteer. Okay, Olivia.
I'm not sure. I plugged everything into my calculator, but then I did not know what to do.
Okay, so when you stuck it into your calculator, where did you stick it in?
I put it in stat edit in the L1, L2 lists.
Good. And then you add to L1 and L2. Good. You'll get your table. So here's L1, here's L2, and you'll put your LSD concentrations and then your math score. Okay, and then, okay, thank you, Olivia, for starting that off. Layla, are you here now? Douglas, what would you do next? Try to find the correlation or classify the relationship.
You would do stat, calc, 1 bar stat.
Okay. Okay, so if we do stat, calc, 1 bar stat, what does this give us?
Me?
Douglas?
I don't know.
Well, look at your calculator.
I didn't plug it in yet.
Okay, so
for all the values.
And I get a mean value. I get the sum of the means. I get the standard deviation.
Can you make your screen brighter because we can't see the calculator?
Okay, hold on, Chloe. I think, let me fix my, I think that my thing for somehow is using L1 and L2 because it had my N as 4 instead of 7 because we have 7 data points. Because my calculator for some reason wants to use the other. Okay, there we go. So, okay, so when we do this, we get like mean and we get standard deviation. Is that going to help us classify the relationship? Does that look at correlation between these two variables?
No.
No. So instead of this, what you're going to do is you're going to do stat, calc, and then you're going to do lin reg. Okay, because the linear regression, so this is what you want to do. We're not going to do this. We want to do this guy. Okay, and when we do lin reg, you should get, see if I can make this a little bit better. It's not terrible. I'm going to zoom in. Okay. So when we do lin reg, we should have, we get our slope value, which is A. We get a y-intercept, which doesn't really matter. And we get our R value, okay? So our R value for this is what we really care about, and it's negative 0.936. What type of correlation do we have here? Izzy.
Strong negative.
Yeah. We have a strong negative linear correlation. Okay. We could even plot the linear regression excuse me, line using the given slope and the y-intercept. Okay. What questions do you guys have on this now?
Is that all we were supposed to do?
Yes. That's it. Just finding the correlation between the two variables. Okay, so it's not difficult, but it's something that we need to remember, keep in our back pocket. Okay, we can't just like take a test and totally drop all the information. You gotta remember how to do this. Okay, any more questions before we move on to notes for today? Okay, if there are no questions, I'm gonna move on. All right, so today, our notes, we're gonna start probability. Let me make the screen as big as it can be. All right. All right, so we have our intro to probability for today. If you printed this out, you probably have all the pretty colors on here, but I don't. It's fine. All right, so we have several examples at the top, and these examples should be fairly straightforward, pretty much like review. So we're going to go through those first, and then we're going to talk about the little terms to know at the top. Okay. So we're going to start with number 1. It says a fair die is thrown. What is the probability of obtaining a 5 and an even number? Okay, so Sienna, can you tell me what is the probability of rolling a 5?
One out of 6.
Yep, perfect. So 1 out of 6 is going to be our answer for part A. We're just taking the number of 5s that are on the die and then the total number of sides on the die. Okay. And then, Claire, can you tell me what the probability of rolling an even number will be?
1/2.
Whoa, yes, 1/2. So we have 3 possible even numbers out of 6 total sides on the die. This simplifies down to 1/2. Thank you. Okay, so fairly straightforward. Let's do example 2. It says a bag contains 4 black balls and 6 white balls. A ball is chosen from the bag at random. Excuse me. What is the probability of choosing a white ball? Miriam, what do you think? Miriam, are you there? Okay, message me if something's going on. Kelly?
2/3.
2/3. So, how'd you get that?
Oh no, it'd be 3/2. I got them mixed up.
Wait, 3/2? Why the 2? 3 is bigger than 2, so then you have a probability that's greater than 100%. So how many, so it asks what is the probability of choosing a white ball? How many white balls are there?
It would have been 6/10.
Okay, good job. It's okay. So 6/10, which reduces to 3/5. And that would be our final answer. Good job. All right. There are 2 example 3s. I'm sorry. I don't know. Maybe it's fixed on the other one. This should be example 3. This should be 4. It says when our class. Oh man. Hold on. Oh, I have them switched on my other paper. Okay, so we'll start with this one. It says when a batch of 145 paper clips were dropped onto 6 centimeter by 6 centimeter square paper, it was observed that 113 fell completely inside the squares and 32 finished up on the grid lines. Find, to 2 decimal places, the estimated probability of a clip falling inside the square versus falling on the line. Okay, so this one's a little bit more in depth. All right, but what's the total number of paper clips we have?
145.
Right, we have 145 total, and how many fell completely into the square?
113. Wouldn't it just be 113 over 145?
Yes, it is. Okay, now what about on a line?
That would be 32 over 145, right?
I believe so. Yes. All right. And lastly, Taylor, can you help me out with the last one? Does our class contains, well, how many people does our class contain? Anybody know?
A lot.
A lot.
But since there's 20 attendees, so there must be 20 people.
I guess there's 20 people here now, but Layla is not here.
Hey.
You have 21.
Can anyone else barely hear Miss Roberts?
Okay. So let's see, how many of you guys are there? 11. Oh, that's because I went to the wrong class. Oh my heavens. My junior class is so tiny, as you can tell. 21 of you. Yes, there are 21 total. All right, so let's go back to that. So we have, our class contains 21 people. How many of you have blue eyes? Oh man, this is difficult to do on Teams. So how many of you have blue eyes? Raise your hand in the little raise hand thingy. I don't know if I can see them all at one time, but I'm gonna try. So Shane plus 2 others, is that it? Chloe plus 4 others, so 5 total.
I think the 4